now we move to Cyprus. Dr. Maria Terzi is with us. She'll be talking about the most important thing, even for us who are not professionals in the industry. Can we value data more and still keep our privacy? I want to learn that. Hello, Maria.
Hello, everyone. Hi there. Hope you're doing well.
Nice to have you with us here. Hope it's warm enough and nice in Cyprus. Are you in Larnaca or where?
I'm in Nicosia at the moment, but it is very warm and sunny outside.
Good. Been there. It was always lovely. So I will just confirm if your presentation is visible for us. So if you're ready, it will be our pleasure to see what your startup has to offer.
Yes, I will.
Okay, you just put it on share for us.
Just a moment, please.
No problem. John stole some minutes from you, so you have enough time. Privacy and data security. We see it all. Thank you, Malloc, and enjoy, Maria.
Okay, so hi, everyone. I'm Maria. I'm from Malloc. Malloc is a privacy and data security startup from Cyprus. And I'm really happy to be here today with you and talk to you about privacy and data security in smart devices. So in this session, we'll focus on privacy and data security. We will start from promoting an understanding on how data are generated and used, then discuss more about what is privacy and why it's important for you. And we'll go through some examples of how our privacy is violated today through our interactions with smart devices. Furthermore, we'll discuss why conventional approaches such as anonymization that we use today to preserve our data are not enough. And finally, we'll have a very short, more technical session where we'll go through some state-of-the-art approaches for preserving privacy. So we do live in a fully connected world. We speak online, we buy things from Amazon, we communicate through our phones, we order food through our home assistants, we drive with our smart cars, we listen music to Spotify, we use Fitbit and health bracelets to track our fitness, and we interact with smart devices every day. They are part of our lives. It's a matter of fact that it is estimated that 79 zettabytes of data will be generated from smart devices or internet-connected devices by 2025. What is important is that most of those data are actually our data. They are generated through our interaction with the smart devices. It is the things we say at the home assistant that act on it. It's the data we store on our phones or generated through our interaction with our phones, such as us taking pictures or recording videos, or when we're saving things on our phones that we like. In smart cars, it's the way we drive. Even our weight on the seat matters, our facial expressions when we're driving, the music we want to hear when we are sitting in the car. And companies use these smart devices to take advantage of those data. We have seen multiple incidents in the press where data have been recorded without our knowledge. Smart home assistants and mobile phones that are always listening our conversations. We have seen applications secretly opening our cameras and other malicious applications that steal our data without us noticing. Also, smart devices that record our health data and then can use them for any other reason. Here is one example of how data are used and are of benefit to these companies. There are companies, they're called data brokers, that is their job to collect data from your interaction with smart devices or the internet in general. And then they can provide you as a target for advertising. For example, your purchase history may be able to classify you as a person who is buying a lot, who is a compulsive buyer, and then recommend things on you based on that. or data from your social media. For example, if you are sharing that you're pregnant, then you may be classified as a potential parent and then be the focus of advertisements based on that. If you're playing a lot of games or using specific apps related to anxiety and stress, then you may be classified as a person with depression. All your interactions at the internet generate data, and this data are used to profile you, to make a persona out of you that can then be used for advertising and marketing. And here's one example. I don't know if you have seen this in the press. This was in a few days ago, on the 28th of April, when an Australian I think it was an Australian university actually who identified this, that Facebook can target children that are interested in smoking, alcohol, and weight loss. Through the Facebook ads, you can go so specific to the age and the interests and the habits of specific people. And this can be particularly dangerous. So why it's dangerous and why it's privacy and we should care? So overall, privacy is the ability to control who can access information about your private life and your activities. And it gives you the power to choose who you share with your thoughts and your feelings. Privacy protects any information that you don't want to be shared publicly. It also protects your physical safety. For example, when your real-time location data are public, then your physical safety may be at risk. Privacy helps protect us as individuals against entities we depend on or that they are more powerful than us. And of course, privacy is tied to freedom. Can we really be free and have free will without privacy? One of the ways our privacy is violated every day is through our consent. In smart devices and in software in general, we have what we call the terms of service. And I think you have undoubtedly agreed to terms of service at some point in your life, but have you ever actually read through the entire terms of service documents? There was a recent report from FTC who actually found out that insurance companies gather information from you about your driving habits through a connected car, and then they use them to calculate your insurance rate. The same could occur for health or life insurance when you are recording data on your fitness tracker. On our mobile device, this is similar to the permissions that we grant to different applications. For example, we may allow an application to use our camera, but do we always want them to use their camera even when we're not using the application? Or the microphone. An application may need the microphone in order to make a call, but do we want them always to be able to record us? And here comes the question, have you ever seen advertisements related to things that you have talked about? Have you ever been worried that someone is actually recording you through your smart devices? The last thing is cookies, and this is the way we're getting tracked on a web browser, on the internet. So cookies are used by websites in order to track clicks and likes. So when you visit the website or you use an application on the web, small pieces of data are placed on your device to track and record what you do. And some cookies are actually functional. We need them in order, for example, to remember your username and your password. But there are other cookies which help the company analyze its users and make services more profitable. And there are also the third-party cookies, which are used to sell your data to other companies who want to advertise their product to us. Spotify, for example, allows over 60 companies to place cookies on your device, including Google, Amazon, and Facebook. And in this way, companies can track you even when you don't use their services. So Facebook can know exactly what music you listen to from Spotify, even when you are not logged into Facebook. So privacy in research started gaining interest from 2002 when Swing et al. Published some papers on data aggregation privacy. And in machine learning, we started caring about privacy in 2011. And then we started considering how we can train models by respecting privacy. And a bit after, in 2018, we have the GDPR, which is an excellent framework for protecting personal data, and also the California Consumer Privacy Act, which came out in the 2020. The thing is that these frameworks have some really good policies and really good guidelines, but not all of them can be applied in our technologies today. It's really difficult to go through some of them. For example, in GDPR, there is a clause that says that the user has the right to be forgotten. So if a company uses your data to train some machine learning model, then this company, and if you want to remove the data, then this company should teach the model to forget what they have been trained on, which is something that is really challenging at the moment in research, and we cannot actually go through this. But later in the session, I will mention some approaches that are valid in research today and are actually used by companies. But before we proceed there, let's discuss a bit about the current methods that we use to preserve users' privacy and users' data. And this is actually anonymization and encryption. This is the recommended approach that if you have some data and you want to do some analytics on them or give them to another company to do analytics of them, the guideline says make sure that they're anonymized or encrypted. The thing is that anonymization doesn't really work, and this actually was we got evidence about this very early. In 2006, Netflix has announced a challenge for 1 million, and the challenge was if you can use users' ratings in order to produce the best recommender system for Netflix. So to produce the algorithm that will be more accurate in showing users the movies that they would like to see. So 2 years later, some very clever researchers got the anonymous data set that Netflix has published for this challenge, and they put it close to an IMDb data set. So they got the data set from Netflix, which was anonymized and contained no personal information, no the name of the users, nothing about them. And they then got some data from IMDb. And when they put the movie ratings next to each other, they were able to identify most of the users that have rated those movies. And this is the attacker advantage of accelerated information. So if you combine this data with some other data, then you can de-anonymize them and start making sense of them. Another very popular example was the re-identification of the Governor Williams Wealth medical records. So here, there was a student who actually got the medical data that have been published in Journal of Medicine and Ethics. They were publicly available for many years. And this data had no personal data, so they didn't have the name of the patient or the surname. The only information that it contained was ethnicity, the visit rate, the diagnosis, the procedure, the medication that it took, the charge, the zip code, the birthday, and the sex. So this student bought the voters list. This was a student for MIT. She bought the voters list for $20, and she put the voters list next to those data. And only based on the zip code, the birth date, and the sex, she was able to identify 64% of the patients that have been published in those data. And this is like the most prominent example of how anonymization can be achieved, again, using auxiliary information. So by combining those data with other sources of information that are available. There are few more examples. I think this was in 2006. AO actually published the search logs of many users, and they did that in order to help researchers. And only 5 days later, some people from the New York Times were able, through the anonymized search logs, to identify one woman, Thelma Arnold, and they were able to identify her because her search queries contained things about her dog and about her husband. So they were in the village that she was living in. So they were able to track her down and actually get a picture from her. So imagine how she felt when when everyone knew about her search history over the last, I don't know, 10 years maybe. The same thing is happening a lot on social networks, but I will skip that to be a bit faster. This is another example where some researchers installed a smart meter. It was just a smart meter that tracks the data that the house was sending to the internet. So they were just monitoring the traffic, the internet traffic, the data traffic that was left from the internet. And through this traffic, they could identify what TV show was the TV playing. So it was a digital TV, and through the data transmitted, they could figure out specific content that was actually viewed on the digital TV. This is an interesting map. I don't know if anyone has come across it. It was published by Strava. Strava has more than 30 million users around the world who are using the application. And you use this application either on your smartwatch or on your phone, and it tracks your fitness and your jogging around the area. So when they published this first image, they were really proud of all the people that use their software, and they wanted to demonstrate it to the world. What they didn't notice is that actually they released a weird shape in Afghanistan, and people, and it was in the middle of nowhere, really, in Afghanistan, and without them knowing, they revealed the largest US military facility in Afghanistan. So probably the soldiers were actually using the software and on their watches or on their phones, and they were doing like jogging around the area. So using this way, they didn't really know, but their data have been recorded and they have been accidentally published, and then this military base was relieved. And also, this happened in Sahara. So there was also a French military base in Sahara that got revealed through this map. And if you saw the map, it was just a little dot. So it was interesting that there is a small dot in the middle of the desert. And actually, this also happened to me. I use another application. It's called Map My Run. And when I go like jogging around Nicosia, it registers my track and how many meters I have spent, etc. What I noticed is that actually they can show me information about other users that are using the app. So I know that Michael Dimitriou is doing this particular route every day, and also Nikos Konstantinou is doing this route every day, and they can actually track them on time as well. Another popular example of how data have been leaked was the casino and the fish tank. I don't know if you have heard of this, a bit famous. It happened in 2018. So there was an internet connected fish tank, and hackers got through the fish tank, and then they went to the servers and got all the data. And of course, we have the data that are exposed, maybe without even the understanding of the company that provides the data. And we also have data breaches that happen in many smart devices and users. This is another example, because I mentioned machine learning before, and I have mentioned how hard it is to forget something. In this example, they have used a model, a pre-trained model, and actually through the model, they were able to infer back to the data that have been used for the training. So this was a model for images, for face images, and they were able to go back and reveal what are the original images that this model was trained on. So obviously, anonymization or encryption is not enough to preserve our privacy. And before we go to the technical part and explain some of the state-of-the-art approaches for privacy preservation, I would like to discuss a bit what is privacy and how we can better define it so we can better protect our privacy and our data. And the best definition that we can use in order to protect our privacy and our data is the one of differential privacy. And this was introduced in 2014 by Cynthia Twork. Actually, she has a book. It's called The Algorithmic Foundations of Differential Privacy. And it goes like this. Differential privacy describes a promise made by a data curator to a data subject. And it goes like this. You will not be affected adversarially or otherwise, but by allowing your data to be used in any study, no matter what other studies, data sets, or information from other sources is available. So this captures the combination of data with other auxiliary information, or the matching with other information that we can find online in order to re-identify people. Differential privacy is also a technique that is used, and in technical terms, you can design it as a query to a database that can return the same value even if you remove any person from the database. So just quickly, let's say that we have stored 4 numbers, number 10, 20, 30, and 50. The sum is 65. If we remove an element, does the sum remain the same? No. So if we remove number 30, the sum, it will be 35. So we immediately know that the number we removed, the data we removed, was the number 30. This is a very simple example of how it works. But of course, you can imagine that we can apply this in different domains. So the principle is that if we remove something from the database and the query does not change, then the person's privacy is fully protected. And the question raised is that, can we construct a query which doesn't change no matter who we remove from the database? And in order to do that, in differential privacy, we add some randomness or some noise to the query to protect the data from things like the differencing attack that I showed you before, from things like if you remove some data, how it's going to change. And I'm not going to get into details about local and differential privacy, but I'm going to explain an example of how we can do this additional noise or this randomization. One of the most popular approaches, which is actually also used by, it was also formalized and used by Google in the later years, it's based on randomized response. It's important to remember that in differential privacy, we try to protect the individuals by introducing some sort of noise in order to achieve what we call possible deniability. So plausible deniability. So we need to be in a condition that we are not sure if something is true or false. And the technique that it was actually used in social sciences when trying to identify and predict a taboo behavior. So this was used in the earliest years when we had communism and they wanted to ask people if they're communists or not. And it was very taboo to say if you are or not. So they used this little technique. So they told everyone, flip a coin 2 times, and if the first coin flip is heads, then answer honestly. If it's tail, then answer according to the second flip. So flip the coin again, and if it's heads, then answer honestly, or if it's tails, don't answer honestly. And what it does, it actually adds some probability of mistake. But if you, and we can also do this experiment, if you are alive, we could do this experiment to pick a number and then add some amount to the number and then remove some amount to the number. So basically we're adding noise or some probability of mistake. And what it does is that having a very large number of reports will actually cancel out the noise. I'm going to talk a bit about federated learning. I think we have a few more minutes. So one of the state-of-the-art approaches now when training machine learning models in order to preserve their privacy is federated learning. So in the beginning, what we used to do in the past was actually sending everything into a server, send all the data into the server. Into the server, you have a machine learning module that will be trained, and then you will use that model in order to provide some predictions or some classifications, etc. However, this is not privacy preserving because you need to send the data of the users or your company to the remote cloud. The other approach is to share nothing. And this is what TinyML is doing, or machine learning on the edge is doing. So what they do is that they try to do very small machine learning models that they can sit on a smart device and do all the processing on the device without sharing any data. But now we have something called federated learning, where you can train your model on the individual devices, yet benefit on the global model by just taking some weights. And we don't have the time to go through this in more detail, but please come to me if you are interested about this. I would like to discuss it and share more information with you about this technique. And this technique has been formalized by Google and is actually used a lot in their text messages and their chat. An important thing when preserving privacy or when you care that your data are protected is that when you're designing a system, in every step, you should ask what information can every step see. So if you're having mobile devices, what the device can see. If you're sending data to the server, to the cloud, what the admin of the server can see, or what the server can see, or what the engineer who is working on that can see, or what the network can see, and then what the world can see. So it's important to analyze very well how are the data transmitted and who can see what. And before we close, I will also like to mention a bit about secure multi-party computation. And this is another state-of-the-art approach that is based on the principles that multiple people can combine private inputs to compute a function. For example, if we like to compute number 5, we can give one person number 3 and another person number 2. So we store number 5, but the two users are holding the individual numbers, and they cannot know the summary, the sum, unless they combine it. So I'm going to close with Malloc and our mission, which is to help people and business protect their data and regain their privacy. And we're very interested in collaborating with other people, and also show you our first application, which is actually available on Google Play Store, which is a mobile app that will notify you when any application is using the microphone or camera of your device. It will tell you which application used the camera or microphone and for how long. And this is one of the first products of the startup, but we're having, we have planned a path of privacy protection in smart devices and with applications in smart cities. Thank you very much for your attention. I'm happy to answer any questions or connect with you later.
Thank you so much, Maria Evgaristo. I need that one for iOS, okay? When you develop it, send it to my email, because I'm a journalist and I would like really to know which app uses it a little bit more than it should be. But believe me or not, that's very interesting to talk about, because now I always read the agreements and ask, can app use my mic? Why should the just game use my mic? No. Can it use? No. It's always no, but it's much easier. Thank you so much for being with us, Maria. If you have, of course, time, visit our platform. There can you find more questions. We wish you all luck and great success with the startup. Thank you.
Thank you very much.
No problem. See you in person. Goodbye.